Section 6.4, example 5, graphing a vertical shift of the parent function. Y is equal to log base b of x. Sketch a graph of f of x is equal to log base 3 of x plus 2 alongside its parent function. Include the key points and asymptote on the graph. So we have our graph f of x is equal to log base 3 of x minus 2. This here is the parent function without any shifts or translations. So let's see what that looks like really quick. So we'll say p of x, the parent function, is equal to log base 3 of just simply x. And we'll get our points x, and this will be p of x. And we could start with all of the outputs first, just because it's a little easier to see that way. So we'll start with an output. Let's do 0. So 0, we have 3 raised to the power 0 is 1. So when we input it here, we'll output 0. So 3 to what power will give us 1? 3 to the power 0 will give us 1. And let's look again. So we'll try -1 here, -2, +1, +2. So let's start with negative, or move on to -1. So when we output -1, 3 to the power of -1 is equal to, in this case, it's going to be 1/3, 1/3. And next for -2, we put -2 over here and turn it in from a logarithmic problem to an exponential problem. 3 to the power of -2 is 1/9. 1/9 here. And moving on to this one over here, 1. So when we output 1, 3 to the power of 1 gives us 3. So we input 3. So 3 to the power of 1 gives us 3. 3 to the power 2 gives us 9. And now let's graph this. So when we input 9, or we could start here in the middle. When we input 1, we get 0. So when we input 1, we get 0. When we input 3, 1, 2, 3, we output 1. When we input 9, 3, 4, 5, 6, 7, 8, 9. Shift this over a little bit. When we input 9, we output 2. And moving closer to this range right here, when we input 1/3, we output -1. And when we input 1/9, we output 2. So this here ends up being our vertical asymptote at x equals 0. Because we start coming in, getting really, really close to 0, but never actually touching it. And out that way. So just as before, out here we're subtracting 2. So we just found all of these values, but now our output is going to be -2. So 2 less than what we input here. So for our function f of x, that's log base 3 of x minus 2. We input all of the same numbers. That's not changing any, but our our output ends up being decreased by 2. So x, and here we have f of x. Our inputs are still all the same, 1/9, 1/3, 1, 3, and 9. And now for each of our outputs, we're subtracting it by 2. So here we have -2 minus 2 gives us -4. Here we have -1 minus 2 gives us -3. And we keep going down. So next we have 0, 0 minus 2 gives us -2. We have 1, 1 minus 2 gives us -1. And 2 minus 2 gives us 0. So now in blue, our function f of x, when we input 9, we output 0. When we input 3, we output -1. When we input 1, we output -2. When we input 1/3, we output -3. When we input when we input 1/9, we output -4. And keep going. It looks like we have the exact same vertical asymptote. At x equals 0. Which makes sense because our asymptote comes from the inside of our log, and the inside of our log is the exact same for the parent function and the function itself. All right, so we have that. Let's look at our domain, our range, and the asymptote. Domain is restricted because we can't have any numbers 0 or less inside of the function. So our values are starting off here at 0 and going off into infinity. So 0 to infinity. Our range, as we go further and further, or closer and closer to 0 from the right side, we go further and further down to -infinity. So that's where our range starts. And as we move further and further right, even though it's gradually going up, we're still going up exponentially. So it takes off a lot further in the x-axis or logarithmically. So this is still infinity. And now our asymptote. So our asymptote is here at x equals 0. There we go. If you have any questions, please feel free to ask. Otherwise, bye.